In this section, we're going to implement the remaining features of our web app. These include new views and support for editing and deleting of job postings, as well as an admin dashboard with analytics data. And all of this is going to be accomplished within a multi-role system, so certain users will have permissions that others don't. There's a lot of work ahead of us, and we'll have to use every API and pattern that we've seen in the course so far, plus learn a couple of new ones. We'll start relatively easy by adding the remaining public content. These are pages that can be accessed by users who are not logged in. We're also going to add some polish to our web app by implementing loading indicators and by adding our search bar feature. First off, you'll notice that we have a footer section at the bottom of our app. This was not there before. And as you can see, these links open some general static pages that are meant to be a placeholder for legal documents such as terms and conditions. There's actually not much to say here, but let's go over the code quickly. The footer component is a simple collection of links and a copyright message, all of which is neatly arranged using Flexbox. The static pages themselves are also nothing special, but you'll notice a new set of components that I've extracted to a directory called typography. These are useful, reusable elements for various purposes. Remember to always build out these small component libraries so that you can keep consistent styles throughout your web app. Moving on, you'll notice a loading spinner on our main page. It's there for a second or two and then it disappears, followed by the list of job items. You'll see in the job list page a separate render condition that presents a spinner if the loading indicator is currently set to true. The spinner itself is an open source component written by a GitHub user Nobody, and it uses SVG and CSS animations to create a simple yet stylish spinner. Feel free to check out the code in the provided files to see how it works. Now, I had to place a longer timeout value in our getJobsMocked method in order for there to be enough time for the spinner to actually be visible. Let's change that to something shorter now that we've seen the demo. Oh, and don't worry about this search query parameter, we'll get there soon. For now, let's also add the spinner component to our login page. We also want to make sure the login button is disabled when a login attempt is currently in progress. Excellent. Another thing we need to wrap up is a page for our individual job postings. I already have some code in the background for this, so let's unravel it step by step. If we examine the blocks on our homepage, we'll notice that they're wrapped in actual semantic links. If we check the jobs demo data, we'll see some new additions. There are a couple of new properties here. For example, there is a slug property, as well as a promo image URL and an apply at link. And by now you've probably guessed that we're using the slug to have a friendly identifier for job postings in the URL. If we open the job list element component, we'll see that that is indeed the case. We've also updated our prop types to mark the slug as a required property. And there is something that will happen when we click on those boxes. A new page opens up with a familiar looking card, a broken link button, and a nice promo image in the background. Just to confirm, every job posting has a unique slug, a different promo image, and the link, while not very well styled, is an actual link that leads to an external website. Now here's how we've defined this route. You'll recognize this dynamic parameter syntax from our first video on React Router. We're using it so that our job page component can figure out which job it's supposed to present. If we jump inside of the component itself, we'll notice a style component that's used to display the promo image. A familiar component didMount method for loading data from the API is also here, as well as a simple render method that places a job list element card and a link inside of the background image. The getJobMocked API method accepts a slug parameter in order to fetch the requested job from our data. We've provided this parameter through thisProps.match. This is a property that's provided to us by React Router and contains the params object with the slug property. The getJobMocked method then returns the requested job object if one exists. We don't have to mock an error version of this method because we just need to visit a non-existing slug, and this method will return an error anyway. The job page currently doesn't really display an error message, nor a loading indicator. As we've learned how to do this, let's go ahead now and add one. And to test it out, we'll visit a non-existing slug. We'll also add a spinner component, and we need to update the getJobMocked method to resolve after a second or so that we can simulate some network latency. Excellent. This looks much smoother than before. Let's also solve the problem with the styling of the link button. If we look at the external link component, we can see that it takes the primary button component and replaces the button element with an anchor element. To achieve this, we use the styled component's built-in method called withComponent. And then we extend this so that we could add some additional styles if needed. But why doesn't the link look the same as the button right out of the box? This should work, right? And if we inspect in the console, we'll see the styles from the primary button are indeed there, but the ones from the root button component are not. To fix this, we'll use the extend method, which allows the styles to be passed down the extension hierarchy. Okay, that's much better. We'll just get rid of the underline by setting text decoration to none, and that's it. Now, before we close this video off, there is one final feature that we need to implement, and I teased it earlier, the search bar. That's right, you'll notice that the search bar is actually working like a filter now as I type. So how does this work exactly? Well, it's actually a lot simpler than you might think. In our app.js component, you'll notice a new method called handleSearch. And all this method does is take a value from some event and then push it to the URL as part of a search parameter. And you may have noticed that the URL in the top bar is changing as I type. This is then passed down to the navigation component where it's provided as a callback to our input component. It's that simple. We've linked our navigation bar to the handleSearch method. Now, one of the things I've noticed, and it's kind of annoying, is that if we delete the value from the search field, there is some leftover search parameter in the URL bar. To solve this, we can add a simple if-else condition to our handleSearch method. Or, if you find it more readable, you can actually add a ternary operator like we've done so in the past. In fact, everything will fit on one line if we do it like that. Now that's a matter of preference, but personally I like this a lot more. Excellent, so this works much better now. Now, we've solved the mystery of how the URL is changing as we type, but how is the job list component responding to these changes and filtering the data? If we jump into this component, we'll see that it's using the component didUpdate lifecycle method along with the component didMount. So what's the deal here? Well, as you can see, we were smart and we extracted our job loading function into a separate method called loadJobList. And we call this method once when the component first mounts, and then we call it again and again every time the URL changes. This is thanks to the component didUpdate method, where we're comparing if the previous search parameter is different from the new one. In the loadJobList method, we extract search query from the URL and then provide it to our getJobsMocked function. This method has been modified to filter out any job that doesn't contain the search terms in the title, if the search query is actually defined. And as you can see, we're calling two lowercase on both the title and the search term so that we can ignore case sensitivity. And if you're unfamiliar with the indexOf method, here's basically how it works. It returns the index of the search term within the host string. If it returns -1, then that means that the term does not exist in the host. If it returns 0, then that means that the search term is the first thing in the host string. So there you have it, a set of really cool features built by using various things that we've learned in the course so far. But we're not stopping here, however.